Thanks, and thanks very much for the opportunity to be here. We're not going to talk about funding because everything that was in my bio changed, shall we say, and that's all we're going to say about funding. Yeah, thanks everybody for coming. I'm going to try and give a sort of a whip through of where we are in terms of big concepts in HIV vaccine design. Those of you know me know that I always focus on antibodies, so you'll see it's an antibody-heavy talk as usual. There's also quite a lot of data in some of the slides which I'm not going to discuss at all. I want to get through the concepts rather than get into the details, all of which are published. But the first challenge is going to be whether or not I can break the podium. And I wanted to start with this slide, which is a reminder of how variable HIV is. I get, and I'm sure all of you get the question often about, if it was so easy for us to come up with a vaccine as a community for SARS-CoV-2, why is it so difficult for HIV? And this slide really summarizes how vastly different the two pathogens are. On the left-hand side, each one of those colored ticks is a mutation, and you can see SARS-CoV-2 is fairly mutated, as we know, which is why those vaccines became problematic quite soon. But HIV is just like orders of magnitude more variable. Each one of those colored dots is a mutation, and the amount of variation in one person living with HIV is equivalent to global diversity for flu. So we are dealing with a very different beast here in terms of vaccine design. One of the reasons that we have hope that an HIV vaccine could trigger broadly neutralizing antibodies, which are the kinds of antibodies that would be able to recognize that huge diversity of viruses that we know exists, is that some people do naturally, after many years of infection, and that's the key, after many years of infection, they do make those broadly neutralizing antibodies. And so while those antibodies don't benefit the people in whom they develop, the hope is that if we can get those antibodies and trigger them by vaccination beforehand, then that would be a different outcome. And people like my team have spent decades, and literally decades, studying one or two or three individuals who happen to make those broadly neutralizing antibodies and really defining the arms race very carefully and understanding exactly how those antibodies developed in people who did develop those antibodies. And understanding that pathway, which has, as you can see, been the basis of many wonderful collaborations and many wonderful PhD and master's projects, means we have a roadmap now in terms of understanding what we're trying to do. We've studied people who are living with HIV, we understand how it happened in them, and now we can try to replicate that process without the virus by vaccination. And that's what is now the basis of a phrase you'll hear often in the field, which is rational vaccine design strategies. And when I was showing my slides to my 16-year-old kid, he said, huh? So what have you guys been doing for the last 20 years if what you've been doing up to now has not been rational? Which is a fair point, I thought. What we mean here by rational vaccine design is an even more engineered version of what we were trying to do. We used historically kind of more empiric ways of trying to design vaccines, but now we're going back to that roadmap that we have learned from people who are living with HIV who develop broadly neutralizing antibodies, and we're copying it literally at the molecular level. So it's a much more thoughtful, careful, orchestrated program of trying to drive B cells along the right pathway, even though it is a bit of a silly name. So I said I wanted to cover some of the key concepts that I think are changing the field. I'm not going to try and cover everything in 15 minutes, and I know Betty speaks after me and will cover some more of these concepts, but I really wanted to touch on four main approaches that I think may change the HIV vaccine landscape, have already. The first is something called germline targeting, which you will have heard a lot about in the field. The whole field seems obsessed with germline targeting at the moment, and I'll try to explain what that is. But three other concepts which I think are worthy of focusing on is the idea of actually immunizing people living with HIV. So this is testing vaccines in people who've already become infected, and I'll explain the logic there. Pediatric trials of vaccines, and then slow delivery immunization. And the reason I'm focusing on those four concepts is I think they have the potential to shift the HIV vaccine landscape, but also other variable pathogens. So germline targeting is based on our understanding now that those people who made broadly neutralizing antibodies do so because very, very, very rare, ultra-rare precursors in their bodies were stimulated. So it's like looking for hen's teeth in those individuals. If we were to apply germline targeting to this audience, each one of you would have between 1 and 3 of the correct B cells. Only 1 in 3 of the millions of B cells that you have in your body. And what germline targeting tries to do is to engineer a vaccine that specifically goes in and finds those 1, 2, or 3 B cells that are in your bodies and stimulates them to become more. And the idea is that by finding those hen's teeth precursors and setting them off along the right pathway, you can drive them towards broadly neutralizing antibodies. This work was, it's unbelievably elegant immunological discovery work, published now not so recently, 2023 in Science. But I just wanted to make the point that these germline targeting vaccines have shown great promise in the sense that they can activate those 1 to 3 precursors. But actually we have a very long way to go before these antibodies become a true vaccine. We are literally taking the first step in this strategy. And so when people say we have an HIV vaccine in the form of a germline targeting vaccine, I would argue that that's not yet a reality, and we need to be very careful, I think, in how we describe the immunology. So we've taken the first step in germline targeting towards triggering the right vaccines, but have a very long way to go. And I think that's clear from the way in which we measure success in these germline targeting